All right, so let's look at these last two examples from the previous video. And notice we have this expression f of t minus c times uc of t. And then over here, we're actually using it for a specific function f, right? So if we're trying to find the Laplace transforms of various functions, we may want a formula for the Laplace transform of this function in terms of f. And so that's exactly what we're going to find in this video. If we have the Laplace transform of some little f is big F of s, then we're going to find the formula for the Laplace transform of uc of t times f of t minus c. And we're going to do it once from first principles, and then we'll be able to memorize or look this up in the future and not have to worry about deriving it this way again. But doing it this way so that you believe me, and because it's sort of fun to do it once. Okay, so this is the definition of Laplace transform. I just rewrote that function there. And then uc of t is a step function, so we're going to integrate the parts separately from 0 to c, and then after t minus c e to the minus st dt, and then adding c to infinity uc of t f of t minus c e to the minus st dt. And then uc of t is 0 here, so that whole integral is 0. It's definite integral of 0, plus the integral from c to infinity. uc of t here is 1, so 1 times that, or f of t minus c times e to the minus st dt. And now I'm going to do something sneaky, and I'm going to switch variables. So letter we haven't used yet is v. I'm going to let that be t minus c. What does that do? That means dv equals dt, so that's good. And as t goes from c to infinity, v goes from t minus c, right? So this is 0 to infinity. We can change the bounds. And then also we'll need this substitution, t equals v plus c. We just get that from this equation. Okay, what does that mean? So I'm going to leave the bounds empty for a minute. This is f of v e to the minus s, t is v plus c, dt equals dv, and then we've switched completely to v, so bounds are going to go from 0 to infinity. And now we've got some exponent rules happening here, but basically what we're trying to do is we're trying to create the Laplace transform of the original function, which looks like it's happening here. I just have an extra factor of e to the minus sc. So I'm going to take that out in front because e to the minus sc doesn't depend on v, so I can take it out as a constant. Integral from 0 to infinity, f of v e to the minus sv dv, and at this point you can replace v with t again if it makes you feel more comfortable. But basically this is e to the minus sc, the Laplace transform of little f of t, where I used v instead of t. It doesn't matter. Which is e to the minus sc big F of s is what we called it at the beginning. Okay, so we can we don't have to do this work again. We can just memorize or look up that Laplace transform is this. And then what we're going to do is we're going to copy this function that we were working with. So this orange thing, we'll find the Laplace transform of that. So let's see, g of t is f of t minus 5 times u5 of t minus u10 of t times f of t minus 10. I'm copying that line. Okay, so then the Laplace transform of g of t is going to be the Laplace transform of the first part. Laplace transforms are linear, minus Laplace transform of the second part. And then for both parts, we can use this formula. So the first part, c, is 5. So this is e to the minus 5s times the Laplace transform of the original f, which, let's just make sure, in this case was t over 5. So Laplace transform of t over 5. Minus, and then same formula, But instead of this 5, we have a 10, e to the minus 10 s Laplace transform of t over 5, same function. Right, this 10 changes, but the function was t over 5. Okay, so now we can factor this out, the Laplace transform, and actually we can take a 1/5 out since Laplace transforms are linear. So we can have 1/5 e to the minus 5s, let me try to make the 5's and the s's different, minus e to the negative 10s times Laplace transform of t, which we've calculated in an earlier video, or if you don't remember, you can look it up in the table, but that's 1 over s squared. So we'll just put an s squared here. E to the minus 5s minus e to the minus 10s. Okay, so there's this property and use case for it.